Okay, so in this lesson, we're going to determine whether or not a solution works within an equation. So your goal for today is I can determine if a value makes an equation true. So let's go ahead and get started. Okay, so how do you determine if a solution works? So a solution works if it makes the equation equal. And you know it's equal if one side equals the other side. And we talked about this a little bit with equivalent expressions, how we would simplify them as much as possible and say, okay, does this equal this? So if it is equal, the left side must equal the right side. All right, let's go ahead and take a look at some. So here we have example number 1. We have A plus 23 equals 92. And it's telling us that A equals 61. So just like when we evaluated expressions, we're going to put the 61 in for A plus 23 equals 92. Now go ahead and add 61 plus 23. And so this equals 84. And we bring down the rest of the problem. Here's our equal sign, 92. So is it true that 84 equals 92? No. So the solution does not work. Let's try another example. Example number 2. We have 60 divided by C equals 6. So C in this case is equal to 10. So I'm going to put it in. And remember, you always put it in parentheses. So we have 60 divided by 10 equals 6. So what is 60 divided by 10? Well, it's 6. Bring down the rest of the problem, equals 6. So is it true that 6 equals 6? Yes, the solution does work. Let's try another one. Example number 3. So we have some decimals here. 3.2n plus 4 equals 20. And in this case, n equals 3. So let's put it into the equation. And the reason why we're calling these an equation instead of an expression is because equations you can solve all the way down to get an answer, a numerical answer. Whereas with expressions, you always end up with some sort of variable in your answer. But with equations, you always end up with a number for your answer. So let's go ahead and put in the value for n. And n equals 3 plus 4 equals 20. So order of operations tells us we need to do this multiplication first before the addition. So I'm going to come over here. 3.2 times 3. So 3 times 2 is 6. 3 times 3 is 9. And how many numbers do I have after the decimal? 1. So I'm going to come over here. So that equals 9.6 plus 4 equals 20. Now I'm going to add these two together. 9.6 plus 4. And you'll notice I put the 4 under the 9 because it's a whole number and I put my zeros as placeholders. So 6 and 13. So this is 13.6 equals 20. Is that true? No. The solution does not work. Okay, let's go ahead with example number 4. And remember, if you need to pause the video or rewind it to see what I did, you need to go ahead and do that. Okay, example number 4, I have 1 over 5x minus 3 equals 7. And in this case, x equals 20. So I have 1 over 5 times 20 minus 3 equals 7. Okay, so I need to do this multiplication first before the subtraction according to order of operations. So let me put this over 1. So 1 times 20 is 20. And 5 times 1 is 5. And so 20 over 5 equals 4. So 4 minus 3 equals 7. 4 minus 3 is 1. 1 equals 7. Is that true? No. 1 does not equal 7. The solution does not work. All right. Now, I'm going to have you go ahead and try these on your own, and I will reveal the answers. So you're going to want to pause the video right now for just a second, and then resume it once you're ready, because I have the answers behind this shade right here. Okay, I'm about to reveal the answers. So for number 1, the solution does work. 29 plus 33 does equal 62. So yes, it does work. For number 2, the solution does not work. 1/2 times 20 equals 10, not 5. So the solution does not work. Okay, number 3, 2.90 times 10 minus 1 does not equal 28. Does equal 28. I'm so sorry. I was looking at that, because 2.90 times 10 would be 29, and 29 minus 1 equals 28. So the solution does work. I'm sorry about that. And then for the last one, 24 divided by 3 equals 8. It does not equal 7. So the solution does not work. All right, now we're going to take this up a level. So if you were confused with the last part of this lesson, you need to stop and rewind and go back and do those practice problems again, or ask me for help, because we're just going to get a little bit more difficult now. Okay, so with example number 5, we need to figure out which one of these numbers in the set makes this equation true. Okay, so what we're going to have to do is test each one to figure out which one works. So let's start with the first one, 2.5. So I have 2.5 plus 1.75 equals 34.25. Now remember, you should have your calculator. So with these, it's just a lot quicker if you use your calculator. So 2.5 plus 1.75, and that's going to give you 4.25 equals 34.25. Is that true? No. So 2.5 is not the answer. Let's try the next one. 17.5 plus 1.75 equals 34.25. Again, use your calculator. 17.5 plus 1.75, and that's going to give you 19.25 equals 34.25. Is that true? No. So this does not work. Now, before you jump the gun and say, oh, it has to be the last one, you need to make sure it works, because in some situations, I may give you a set of numbers and none of them work. So you need to make sure that you try all of them. So we have 32.5 plus 1.75 equals 34.25. Again, go ahead and put it in your calculator. And you should get 34.25 equals 34.25. So does that one work? Yes. So the answer to this is 32.5. Okay, let's move on to example number 6 here. So again, I have a set of 3 numbers, and I need to figure out which one makes this equation true. So I have 15 times, and I'm going to use 4 first, equals 90. So put it in your calculator, 15 times 4. It should give you 60 equals 90. Is that true? No. So 4 will not work. Let's try 5. 15 times 5 equals 90. Put it in your calculator. You should get 75 equals 90. Is that true? No. So it's not 5. And again, before you jump the gun, make sure you check them all because it may be that none of them work. 15 times 6 equals 90. Put it in your calculator and you should get 90 equals 90. That does work. So your solution is 6. Okay, let's try example number 7. Do not get overwhelmed by the fractions. Okay, it's going to be all right. Okay, so we're looking for 2 over 5x minus 8 over 2 equals 0. So we're going to go ahead and start with our first number in the set. So 2 over 5 times 20 over 10 minus 8 over 2 equals 0. So let's multiply these across and you're going to get 40 over 50, minus 8 over 2 equals 0. Okay, so just by looking at this, make sure that you can solve this a couple different ways, okay? You can sit here and go ahead and find a common denominator and then go ahead and subtract it. But if you're just using some common sense here, make sure that both of these fractions are as simplified as possible. And to make this one as simplified as possible, it would be 4 over 5 minus 8 over 2 equals 0. Now, in order to get 0, you would need one number minus the same number, correct? So, is it possible that this is the answer? No, it's not. Let's try 30 over 10. So, I have 2 over 5 times 30 over 10 minus 8 over 2 equals 0. So up here, I have 2 times 30 is 60. And then I have 5 times 10 is 50. Minus 8 over 2 equals 0. Simplify this guy as low as possible. You'll get 6 over 5 minus 8 over 2 equals 0. Use your common sense. In order to get 0, you need one number minus the same number. Are these the same? No, it will not work. Let's try the last one. So the last one was 100 over 10. So I have 2 over 5 times 100 over 10 minus 8 over 2 equals 0. So 2 times 100 is 200. 5 times 10 is 50. Minus 8 over 2 equals 0. Simplify down as much as possible. 4, this will simplify to 4, minus, and 8 over 2 also simplifies to 4. 4 minus 4 equals 0. That is the solution to your equation. Okay, you go ahead and try these, and I'm going to show my work at the same time, and then we can compare answers. Okay, if you're not done yet, go ahead and pause the video. If you are done, let's check your answers. So for the first one, your solution was 12 because 12 times 5 is 60. For your second one, your solution was 44.77 because if you add that to 30.23, it's going to give you 75. And for the last one, none of the solutions worked, and so there is no solution in your set. All right, that is the end of this video. Remember to rewind, fast forward, or pause, and always ask me questions in class.